Welcome to the channel. In this series of stereochemistry, we are looking for some of the basic fundamental concepts which are essential to understand the stereochemistry in a better way. In this series, we have already covered the topics, namely degree of unsaturation and the functional groups chemistry. So how you define the functional groups? What are the types of functional groups? All these points we already covered in the previous classes. To visit these videos, you can see the description. We can see the link related to degree of unsaturation and the functional group chemistry. In the today's lecture, we are going to consider one more basic concept which is essential to understand the stereochemistry is the Iupac nomenclature. What is this Iupac nomenclature is all about? Iupac is nothing but International Union of Pure and Applied Chemistry, stands for Iupac. What does Iupac do? This is an organization which has the responsibility to frame the rules to nomenclate any chemical entity. So they have framed certain rules, and there is certain rules specifically derived for the organic compounds. How to name these organic compounds? For that, the Iupac has recommended or framed the 5 different entities. What are those entities? Let's see over there. First entity is called as secondary prefix. Then there is one more entity called as primary prefix. Then there is called as the word root. After the word root, there is something called as primary suffix, and then lastly it comes to be secondary suffix. So prefixes and suffixes along with the word root gives me something called as the Iupac nomenclature for an organic compound. What is the meaning of these prefixes and suffixes? Namely primary and secondary along with word root. Let us understand these points in detail. In the journey of this one, let us focus first on secondary suffix. What is this secondary suffix is all about? The secondary suffix gives me an idea about the functional group present in the compound. So it gives me an idea about the functional group. You already know in a given organic compound, there may be more than one reactive sites. What is meant by reactive site? Reactive site is nothing but the functional group. There are many functional groups may be present in the compound. Out of that, one which is preferential. How will you decide the preferential? That thing you will observe, which is the preferential order. You will see this preferential order in the description, one PDF, and that PDF contains the preferential order about the functional group. Please visit that. You download that preferential order link, and you will get how to select the preferentiality of the functional group. The one with the highest preferentiality consider as the functional group while writing the Iupac nomenclature. I hope the point is clear. Now, how to identify various functional groups? For that, there is one link is also provided in the description, which provides to how to identify various functional groups and what is their structure is given over there. Let's continue with the second part. What is the second part? Now, after completing the suffix, let us come for the prefix, the secondary prefix. What this secondary prefix tells me about? Secondary prefix gives me an idea about the substituent. What do you mean by substituent? Substituent is nothing but the side chain. What in my side chain? Side chain is nothing but the side chain is nothing but to the main chain. Some of the shootouts are coming out. Some of the substituents, some of the substituents are attached. Those are called as side chains, or some shoot out from the word main chain is called as the side chain. Next point comes here is primary prefix. What is the primary prefix? Primary prefix gives me an idea whether my compound contain any cyclic entity or my compound is having any acyclic nature. Remember that it gives me idea whether compound contain a cyclic or acyclic phenomenon. Basically, remember that we never mention any information about the acyclic nature. We basically tells about if there is a cyclic nature in the system or not. We'll come to know what is meant by that in detail when we take a few examples at the end of the lecture. Now, next thing, Now this is a very important point, what is called as word root. What is this word root is all about? Word root is nothing but the main chain. किसकी मेन चेन होगी? आपको पता है कार्बन कंपाउंड्स में या ऑर्गेनिक कंपाउंड्स में हम मेन चेन किसी कंसीडर करेंगे? कार्बन की. सो मेन चेन ऑफ कार्बन एटम्स. और जब आप इस कार्बन एटम की मेन चेन कंसीडर करोगे तो उसको आप नंबरिंग करोगे. तो कैसे सिलेक्ट करोगे मेन चेन? इट्स अ लॉन्गेस्ट कंटिन्यूअस चेन. अब ये लॉन्गेस्ट कंटिन्यूअस चेन जब आप कंसीडर करोगे तो आप उसमें क्या क्या इंक्लूड करोगे? आप उसमें फंक्शनल ग्रुप या मल्टीपल बॉन्ड को इंक्लूड करने की ज्यादा से ज्यादा प्रोसेस करोगे. नंबर 1. और जब आप मेन चेन सिलेक्ट करोगे उसको आप नंबरिंग दोगे. उस नंबरिंग के दौरान आपको किसी कुछ चीजों को प्रायोरिटी देनी. जैसे आपको लीस्ट प्रायोरिटी शुड बी गिवन फॉर द फंक्शनल ग्रुप, लीस्ट नंबर शुड बी गिवन द or highest priority should be given to the functional group. That is the minimum number should be given to the functional group. Number 1. Number 2, the next priority will be for multiple bond and the least priority will be given for the substituent. What do you mean by substituent? Substituent is nothing but secondary prefix. We'll come to know this point clearly when we consider about the few example at the end of the lecture. Is it clear? So word root gives me an idea about the main chain of carbon compounds or carbon atoms, which is the longest continuous chain, and in this longest continuous chain minimum number should be given to the functional group, then multiple bond and the substituent. That is, this is the preferential order for numbering the longest continuous chain, which is the main chain. Now in this main chain there may be a number of carbon atoms. How many number of carbon atoms may be there? For example, there may be a single carbon atom, there may be a 2 carbon atom, there may be a 3 carbon atom, there may be a 4 carbon atom, or there may be a 5 carbon atom. Similarly, it may have 6 carbon atom, or 7 carbon atom, or 8 carbon atom, or 9 carbon atom, or 10 carbon atom, or 100 carbon, anything. For simplicity, we just consider 10 carbon, up to 10 carbon. If in the main chain, that is longest chain which we have, which is called as a main chain, if there is only one carbon atom, we use the word root as myth. If there are 2 carbon atoms, then we going to use the word root as eth. If there are 3 carbon atoms, then we are going to use the word root as prop. If there are 4, then we are going to use the word root as but. If there are 5, then we are going to use is as the pent. If there are 6 carbon atoms in the main chain, then we call it as a hex. If there are 7, then we are going to use it as the hept. If there are 8, then we are going to use it as oct. If there are 9, then we are going to use it as non. And if there are 10 carbon atoms in the main chain, we use it as dec. So what is this hept to dec? They are the number of carbon atoms in the main chain. And how you decide the main chain is the longest continuous chain of carbon atoms. Now in this carbon atom, we have to give the preferentiality. And the preferentiality will be functional group should give a first preference, then multiple bond, and then the substituent. The point is clear. Let's continue with the next point. And what is the next point is? Next point is the primary suffix. What is primary suffix? In this main chain, if all bonds in this main chain of carbon, that's the longest continuous chain of carbon, if all bonds are carbon-carbon single bond, or there may be at least one carbon-carbon double bond, or there may be, just 1 minute, yes, there may be carbon-carbon double bond, or there may be at least one carbon-carbon triple bond, or a combination of this. Anything can be possible. We can use the suffixes as ANE for a carbon-carbon single bond. All carbon-carbon single bonds are there. At least one carbon-carbon double bond, then we use ENE. And if there is at least one carbon triple bond, we are going to use it as YNE. So this is a whole story about how you nomenclate any organic compound using Iupac rules. It consists of 5 entities: secondary prefix, primary prefix, word root, primary suffix, and secondary suffix. What this primary prefix gives me idea? It gives me idea about the substituent, that is a side chain. Secondly, primary prefix gives me idea whether my system contains a cyclic ring or not. Then word root gives me an idea about the main chain, that is the longest continuous chain of carbon. And in this longest continuous chain of carbon, how I'm going to select? Definitely it is the longest continuous chain, but Along with that, it should incorporate functional group, multiple bonds, and this substituent. The priority, the minimum number should be given for the functional group. That is a priority first given to the functional group. Then numbering should be given to the multiple bond. Second priority is multiple bond, and the least priority should be given for the substituent. Depending on these number of carbon atoms, depending on how many number of carbon atoms in main chain, they can be labeled as mid to dec, depending on how many number of carbon number 1 to carbon number 10. Next point is called as primary suffix. What is this primary suffix is about? Primary suffix gives me an idea about whether in this main chain all bonds are carbon-carbon single bond. So this is related to main chain of carbon. Nothing to do with the substituent or anything else. Okay. If at least one double bond is there, I'm going to use a suffix as ENE. If at least one triple bond, carbon-carbon triple bond is there, then it is a YNE. And then lastly, we talk about the functional group. That is the reactive side. I already told you there may be more than one functional group. There may be more than one reactive side. One which is a preferential will be called as a functional group. Now, how to decide? That thing you will observe, and you will get that information in the PDF given in the description. Please see that PDF where you get the preferential order to decide the functional group priority. I hope this basic idea about nomenclating, the rules for nomenclating the organic compound is clear. Now take one simple example to illustrate how to use this prefix, word root and suffix thing in the specific example. Let's take an example for the consideration purpose. The example I'm going to consider over here is with a molecular formula C4H8. You already know, if I given the molecular formula, I can deduce various possible structures. And to deduce the possible structure with the molecular formula C4H8, I want to find out first what is called as degree of unsaturation. And if you find out the degree of unsaturation based on the molecular formula, there is one formula. Okay, you can see the link given in the description. You will get how to determine the DU. By applying that formula to this molecular formula, we get a DU as 1. What do you mean by DU as 1? DU as 1 implies there may be a X double bond Y, that is a multiple bond, or a ring. So there are two possibilities we can guess. As far as this molecular formula with a DU is equal to 1, I can draw various possible structures which may contain either X double bond Y, that is a compound with only multiple bond. Means what? It implies that there is no ring in the system. The system must be a cyclic. I can draw possible structure with only open chain nature. Let us take a simple example. If I have already have the 4 carbon atoms, I can draw the structure as the 4 carbon skeleton. This is one structure. There is another possibility. I can draw this another structure. Now in this 4 carbon skeleton, I can put a double bond. I can put a double bond at the terminal site. Either I put at this end or this end. I'll put it at this end. Either you put it this end or this end, one and the same. Now second priority, I can put it at the middle. Is it okay? Now, as far as this compound is put it like this, I can label this thing. So this is the longest continuous chain. Now in this longest continuous chain, I have to give the preference. The preferential order is functional group, multiple bond, and the substituent. Now in this case, the functional group itself is a carbon-carbon double bond. So ultimately, there's a multiple bond. So ultimately, preference will be given to 1, the priority number 2, 3, and 4. So what this 1, 2, 3, 4? 1, 2, 3, 4 is a numbering to the main chain. That's a word root. How many carbon atoms are there? How many carbon atoms? There are 4. To this main chain, there is no substituent is there. There is no shootout for this. What is the shootout? We will come to know in the next example. So till then, you just consider this a word root. That is a main chain. Now, how many carbon atoms main chain? There is no cyclic ring. So there is no need to use primary prefix. Though there is no secondary prefix, there is no primary prefix. Now come to the word root. How many carbon atoms are there? 4. So name will be but. Very good. Now there is at least one double bond. So at which position that double bond is there? Position number 1. And hence, as there is a double bond is there, I'm going to use OENE. Not I'm going to use at. I'm not going to use at ANE, because ANE is used only if they're all carbon-carbon bonds are single in the main chain. Is it clear? How do you number this compound? This compound is numbered either side, either this left hand side or right hand side. I'll number it like this: 1, 2, 3, and 4. Again, there are 4 carbon atoms. Ultimately, I can label it as but, very good, dash 2 and in. Very good, but 2 in. Now let's take another example. The same compound you may draw like this one. Now what happened? I can put a double bond at this point. What happened? How you name this compound? This compound is again labeled as but 2 in. Sorry, but 2 in. Why I am writing as a but 2 in? Just one second. This is called as but 2 in. Numbering will be 1, 2, 3, and 4. Probably you will get surprised. Sir, आपने यहाँ पे ये दोनों कंपाउंड तो सेम नहीं है. IUPAC wise they are same. Remember that IUPAC wise they are same, but the structure is different because their arrangement in the space is different. No doubt, this compound is called as, actually this is a trans compound, whereas this is the cis compound. Please remember that cis and trans, these are the prefixes. These are the actually the representation of the geometry. What is the geometry of the molecule? IUPAC doesn't carry the descriptor per se in the name. जब आप कोई भी IUPAC nomenclature होगी, ये cis, trans, EZ, RS, all these are called a descriptor, called as a stereo descriptor. Remember that in the IUPAC nomenclature, we never include these descriptor. Descriptors are never be a part of this. No doubt, as a systematic arrangement, we include it, but actually these are not the part of IUPAC nomenclature. So please understand, slowly we'll start understanding it. But at this point, please understand that these two compounds are having the same IUPAC name, but 2 in and but 2 in. No doubt, their stereo descriptor is trans and cis. I hope this point is clear. If you're not clear, please rewind it and see one more time. You can see how the nomenclature is given. The fourth example with the 4 carbon skeleton is, I can use the 3 carbon skeleton and I can put a double bond at this point. Probably if you are confused how to draw these structures, I already explained this in my previous videos, where I can use how to use the DU to find out or draw the possible structures in probably lecture number 2. Please visit that. The link is also given in the description. What is the name? Listen now carefully. I can use this is as the main chain. Can I use this one? I cannot. Why? Because I know that if I consider this is the longest continuous chain, in this longest continuous chain, I should give a preference for function group, multiple bond, and the substituent. Remember that if I select this is as a main chain, there is no multiple bond include, and hence I have to select this is as the main chain. You may select this is also your main chain, no problem. But remember that this will not becomes your main chain in any case. Okay. If I consider this is as a main chain, then numbering should be number 1, number 2, and number 3. Then what happened? In this case, the name becomes, this is a propene. So name will become prop dash. At one position, yes, there is a in, E and E. But to this main chain, there is a 1 carbon atom as a side chain. Now this is something called a side chain. How to name this side chain or substituent? How many carbon atoms are there in the main chain? Main chain 3. How many carbon atoms in the main chain? 3. Therefore, I use the word as prop. But how many carbon atoms in the side chain? Because I have selected like this one. Is it clear? In this one, this group is the side chain. So this is my side chain. Now, how many carbon atoms in the side chain? 1. So ultimately 1 carbon means meth. Now remember that whenever we have a substituent, we are going to use the attachment as YL. So the name becomes is something called as 2-methyl. 2-methyl prop 1-ene. This is the name for this compound. I hope you clear about it. Why I have written the name as 2-methyl prop 1-ene. Is it clear? So with a molecular formula, C4H8 with a du is equal to 1. I have write all possible structure with carbon-carbon double bond or one double bond. Let's draw the another possibility wherein we can have at least one ring. And you know that whenever I write on the ring as one of the option, definitely compounds will be cyclic in nature. I hope this point is clear for everyone. How many carbon atom skeleton I can draw it as cycle as a ring? Definitely the first is 4 carbon skeleton and the second one is, I'm sorry, these are 4 carbon atom skeleton, or it may be 3 carbon ring with the 1 substituent. Is it clear? Now if I draw this one, what is the name of this compound? Now listen carefully. What is the main skeleton? 4 carbon atom is a skeleton. So this is definitely bute. All carbon atoms are carbon-carbon single bond. So it will be butane. But this is cyclic. Ultimately name of this compound will be cyclobutane. It's a cyclobutane. What is the name of this compound? What is the name of this compound? Let me write down correctly. Cyclobutane. This is cyclobutane. What is the name of this one? First find out what is a main chain. This is one main chain. How many carbon atom? 3. This is a side chain. How many carbon atoms? 1. So this one carbon atom means 1 carbon is a meth, suffix is YL. So ultimately the name of this compound will be methyl. Yes, very good. Then cyclo, very good. And how many carbon atom? 3. Therefore pro. And all carbon atoms in a cyclic ring are single bond. Therefore name will be propane. Methyl cyclopropane or 1-methyl cyclopropane. You can also write it down, or you can write simply as methyl cyclopropane. I hope you are clear about it, how to draw the structures, and on the basis of structure, how you going to nomenclate any organic compound using a simple rule, what is called as secondary prefix, primary prefix, word root, primary suffix, and secondary suffix. Okay, so one more time, please rewind the video, see all the details and apply it to this example so that you will get a fundamental concept of Iupac nomenclature. We don't need to go into much more detail about the Iupac, but fundamentally we must know how to distinguish the compound, because this is a basis. Iupac nomenclature is the basis for isomerism. So that is very, very important point. So next lecture will be about classification, or what you mean by isomerism and how to classify the isomers into different categories. With this, thank you very much.